Now refractive index is therefore written as A mu G equal to sin I upon sin R. Here this represents that light has travelled from air and it has moved to glass. So it is refractive index of glass with respect to air. It is always the refractive index of the second medium with respect to the first medium. Many a times a symbol N is also used to represent refractive index. So both symbols mu as well as N is representation for refractive index. Now the refractive index of a medium helps to know the light bending ability of that medium. That means when light travels from one medium to another, what is the extent it will bend towards normal or away from normal, that is decided by the refractive index of the medium. Now this means that refractive index will measure the bending of light when it passes from one medium to another. Refractive index has no unit as it is the ratio of two similar quantities. Now a ray of light changes its direction when it enters from one medium to another medium. And why did this happen? This happened because speed of light is different in different media. For example, speed of light is 3 into 10 to the power of 8 meter per second, or precisely 2.99 into 10 to the power of 8 meter per second in vacuum, and in air it is 2.98 into 10 to the power of 8 meter per second. Bending of light is due to change in speed of light. So children, refractive index may also be defined in terms of speed of light. So these points which I told you just now, the repetition was only to bring the fact that refractive index is also defined in terms of speed of light, because bending of light is due to change in speed of light in different medium. Now if the speed of light in medium 1, let it be V1, and speed of light in medium 2, let's suppose it is V2, then the refractive index of medium 2 with respect to medium 1 is speed of light in medium 1 upon speed of light in medium 2. That means now I have the light that which is moving from air to, or sorry, from medium 1 to medium 2. So you can write 1 mu 2 is equal to speed of light in medium 1 upon speed of light in medium 2. So light has entered from first medium to the second medium. So the refractive index of the second medium with respect to first medium is given by speed of light in medium 1 upon speed of light in medium 2. Now we have refractive index of medium 2 with respect to medium 1 is equal to speed of light in medium 1 upon speed of light in medium 2. We can, here the symbol N is used. We can also write it as mu, and since light is traveling from medium 1, so we can write 1 and 2. So 1 mu 2 is equal to speed of light in medium 1 upon speed of light in medium 2. It can also be written as N 2 1. This will indicate that it is refractive index of the second medium with respect to the first medium. Now the opposite is also true. That means if the light travels from medium 2 to medium 1, then the refractive index will be given as speed of light in medium 2 upon speed of light in medium 1. Now we know that refractive index of medium 2 with respect to medium 1 is equal to speed of light in medium 1 upon speed of light in medium 2. Suppose the first medium is vacuum, then what will the formula change to? It will be refractive index of medium 2 with respect to vacuum will be equal to speed of light in vacuum upon speed of light in medium 2. This is a situation when the light is traveling from vacuum to any particular medium. It may travel from vacuum to air, vacuum to glass, vacuum to water, anything, but the first medium is vacuum. Then we use the word absolute refractive index. This is the refractive index with respect to vacuum. So remember, we measure the absolute refractive ability of a substance by how much light is slowed down compared to the speed of light in vacuum. Why have we used the word slowed down over here? Obviously, because the speed of light in vacuum is maximum. So whichever medium it may enter from vacuum, the speed will be lesser. So now remember, absolute refractive index, here the symbol n is written, but you know that you can even use mu, is equivalent to speed of light in vacuum upon speed of light in medium 1. So I can write mu 1 or n1 is equal to c upon c1. What is c? C is velocity of light in vacuum. And what is C1? C1 is velocity of light in the medium in which it is entered, or the medium whose refractive index we need to know. So now children, what we can say is that we are aware that refractive index is written as equivalent 1 mu 2 sin I upon sin R, and it is also written as refractive index is also written as velocity of light in medium 1 upon velocity of light in medium 2. So this implies that when we want to calculate refractive index, we can do so in terms of the measurement of angle of incidence and angle of refraction, as well as by knowing the velocity of light in the mediums in which the light is traveling.